Okay, I have a short introduction, and I even can shorten this because Ellen already talked about my main topic, that you shouldn't confuse intra and inter-individual differences. But I have a slightly different touch. Why individuals should be studied at both the person and the population level, not only at one of those levels. Why multi-level regression is well suited for this task. I will present then a two-level model of relationship-specific conflict in students at university, and then a three-level model of change in relationship-specific conflict to make the model more clear. And, have an empirical example. First 18 months at university was what happens there at the relationship at the person level. And then I will extend this approach by replacing time, adding classroom level at a fourth level if you want an even more fancy model, and briefly sketch some limitations of this approach. Now, why is a pure person-oriented approach of limited utility? This is what I like to present when I talk to very convinced person-focused people who sometimes think that it's enough to have only rich information about a single person. Now, consider this example, a diary study of one student over 20 days, interpersonal partners, mother, father, and so on, and you have the conflict scaled from 1 to 5. You see the conflict level is typically low, even for this student. You have even days and odd days. It's replicated within that student, a certain pattern. So most conflict is with father. So the student has some problems with the father and also with the partner, right? But perhaps this is completely boring, and actually it is, because that's the mean of a sample of 110 students. So there's no real information except that that student is average in every respect. But we easily tend, when we have these person-oriented results, we easily tend to interpret this as if you have the intrapersonal contrast as something unique to that person. So this is a mistake that can be easily done if we only look to a person-oriented level, and a pure population-oriented approaches of limited utility are also, and cite Epstein there, great study, one of the first diary studies who recognized that angriness, the trait of angriness, correlates low negatively with the trait of happiness, but as a state, angry and happy correlate strongly negatively. It's hard to be at the same time angry and happy. And there are different other examples. Your typing speed example is a wonderful one. So we cannot, or it's very dangerous to infer intra-individual processes from inter-individual difference results. And to my experience as editor, and I'm on the editorial board of JPSP for quite some years, the most widespread error in psychology is this inference. It's regularly done by social psychologists, particularly. Now, intra and inter-individual covariations are only identical in the case of ergodicity, and also cited this, which implies, in this case, the absence of inter-individual differences in intra-individual covariation. And just to make clear what this means, this would mean that it's enough to study one person and you know all. You can generalize to all people, and it's clear this will never be the case in psychology. Forget about this. This is not an interesting question. We can never generalize in that way. And this means that individuals should be studied at both the person and the population level. Now, why is multi-level regression well suited for this task? Now, we have already seen examples, and these examples all share that we have a hierarchical data structure, we have nested data, And lower level regression coefficients, level and slope, are regressed on predictors at a higher level. And both types of regression coefficients are simultaneously estimated. The alternative would be that you start with individuals, and for each individual, you run a regression, and then you have all these individual regressions, and then you build your data up by looking, for example, for inter-individual differences in slopes of these regressions. But within a multivariate, multi-level perspective, you have estimations where you use the errors at both levels simultaneously, which results in smaller standard errors. This is an important advantage of this approach. For example, waves in a longitudinal study are nested in individuals. We have seen examples about this. So individual growth functions at level 1 are predicted by constant individual characteristics, gender, personality, what you have at level 2. And then you have inter-individual differences in intra-individual change. But this can be generalized to any intra-individual covariations, not only change in time. We have only seen examples here about change in time. These were the only examples for within-person differences. And this is a bit not enough, obviously, from a personality perspective. Now, let's apply this not to time, but to something else. If you are interested in interpersonal conflict, social behavior, social relationships, it seems clear that this conflict is different in different types of close relationships or less close relationships. So you have relationship, or you need relationship-specific conflict ratings, and you can study this in the families. This is often done, but this is a restricted approach because you have peers, you have friends outside of this family, and so on. So really a good approach would be a network approach where you're interested in all significant personal relationships. These are idiographic data. Everyone has a different number of significant relationships, and the composition of the social network is different. This is also a signature of the personality of that person, how the social network is composed of. Now, if you want to do this decently with a multi-level model, you need at least 50 individuals. Why? Because in multi-level models, it's important to have a sufficient number at the highest level, not at lower levels. It can be only 2. So you can study couples where you have at level 1, for example, the 2 partners, husband and wife, and then you have at level 2 the couples, and you are interested in couple differences. But at the highest level of any multi-level analysis, you need at least 50, better 100 cases, because the statistical tests for your significances rely on that level, on the number of cases at that level. Now, to move more to the example now, to make relationships comparable across individuals, they are grouped into 6 relationship categories: mother, father, sibling, partner, peers, other relationships. These are 6, right? Then you can dummy code the categories. 1, if the relationship is from that category, 0 otherwise. And so the units of analysis in this multi-level model are relationships, not persons. And at the higher level, you have persons, and because the relationships are obviously nested in persons. So you can then predict each relationship category by, for example, the big 5 personality traits or whatever you are interested in at the individual level. And this would then be the nomothetic part of this model. Now, I used HLM. There was a question, what kind of, it's not always necessary to use M+, and if you are a beginner, I really recommend to you to start with HLM because it has the best graphical interface. I know you cannot make so many mistakes as you can do with M+, and it's better documented. So better start with that, and then move to M+, which is just great in terms of options, but you really have to know what you do. So this is a HLM notation of this two-level model of relationship. It's simple. You have the level 1 model. Conflict is predicted by these dummy variables, and then you have the error at level 1. And you have the level 2, where you predict now each of those coefficients by the big 5 scores, right? And then you have residuals here. And that's, so you have a regression model at 2 different levels. But it's rather obvious how you can construct this, and you can already anticipate how this can continue to 3rd and 4th level. You simply would predict then, these coefficients at the next higher level, and so on. So it's endless, yeah? But it's very straightforward, this kind of hierarchical model. Now, there's in this concrete problem, in this concrete case, but also in many applied settings, there's a problem. What is the intercept? Where does it refer to? Well, we do not have B for the other category. So the intercept here represents the other relationships in this case, right? We have of the 6, 5 included as dummy variables. If we would include in a model with an intercept also the others, it would not, you get an error message because one is redundant. So in a way, the other relationships represent a kind of baseline expectation for conflict. And you compare, in this model, the conflict with the mother, then with the conflict in other relationships, and so on. Now, this is a bit tedious because all the results are relative to the other relationship. And you may think, well, I'm really interested in the conflict with the mother and the father to see directly the means, for example, and the standard error of this mean. And there's a trick that is not so well known how to do this. And the trick is that you use a model without intercept. It's possible. So you have, in this case, now included also a parameter for other that's not the intercept. There's no intercept. In this case, this is an estimate simply of the mean conflict with others, mean conflict with the mother, and so on. This is nice. You can avoid mistakes because it's not so relative anymore. The problem, however, is there's also a disadvantage. Your significances for the parameters are trivial. They test whether the conflict is different from 0, but we are dealing with a 1 to 5 scale, so it's always different. They are uninteresting. But it is possible, even in this model, to test now differences between specific categories by designing specific contrasts within that model. And the contrast gives the same results as the significant tests in this model, if you compare other with something. Other with mother, in this model, B0, the contrast between B0 and B1 is identical with the B1 in this model. Okay. So there are 2 options how to do this. This does not only apply to, but mostly applies to this dummy coding of groups where this is useful. Now, if you have multiple assessments of conflict, longitudinal study, this model can be extended to a 3-level model, where time points are nested in relationships. Missing time points do not present a problem. Time points may be even specific to relationships. They can be everywhere in time. Although you are, and this is Manuel Völkle correctly noted, that still you are assuming then a certain, you are estimating your changes always for particularly unit of time that you define through your scale, but inter-individually they can vary. This brings us to the 3-level model, where now the G's here, okay, no, sorry. This brings us to this, because the model is not extended to the top, it's extended downwards. So the level 1 model is now for change in time. This is a simple linear change, we assume here. And then you have an intercept and a slope for conflict. And then you predict the intercept by, and the slope here, by your dummy codes for the relationships. And then you predict these B's at the highest level by your big 5 traits. It looks a bit more complicated, but the logic is so straight that at least in HLM you cannot really do mistakes here. Now let's come to the empirical example. Studied were 163 heterosexual first-year students at our university who reported during the first week at university on their personality, social relationships, and characteristics of each relationship. On average, we had 63 relationships for each student, really a complex social network. The assessments were repeated every 3 months over a period of 18 months, 7 time points. We had 3.7 assessments for each relationship on average. Why not close to 7? This is not always missing because some relationships began after entering university. Actually, a lot of new relationships developed there. Other relationships ended. They were not in the relationship anymore, for example, with friends from school. So, it's not the case that a relationship is always there, because we are really studying concrete relationships. These are the units, the main units of analysis here. Now the data were analyzed with a 3-level model. And the first thing you do is you look to the variance components at the 3 levels because they inform about the size of the differences. And if you do this in this case, you see that 42% of the variance is accounted for by relationships, 14% by inter-individual differences. Both are highly significant, so it's important to include both levels. Then if you include time, you have the explained variance. It's called a pseudo R-square because it does not add up nicely. Unfortunately, like in a normal regression, because you have here a multi-level model, so linear change explains 11% of the changes over time. The 7 relationship categories, now it's 1 more because we distinguished between old peers that existed as a relationship before the entrance of university and new peers that were relationships that were formed after beginning university, 24%, and then the big 5 at this level 3 explain 13% more. They were all significant, so there is music at every level, so to speak. And this is the result. It looks terrible. Just give you some idea of how to read this. You have, for example, let's look to this red thing here. That's the level 3 overall intercept. So that's the average conflict across everything. That's 1.5 on a 1 to 5 scale. That's typical. Yeah, conflict is not very often. It's socially undesirable. But then we have, for example, the differentiation by neuroticism here. This refers to the intercept, so to other relationships. This is now the effect of neuroticism, which means that if people increase 1 point on that neuroticism scale, their overall level of conflict is 0.2 points higher. And this is highly significant, but that's not dynamic, that's just a level. But we can look here at the slopes. You see that there is a marginal increase of conflict in other relationships. And interestingly, although the more neurotic students have a higher level of conflict, which is what you might expect, it's decreasing. And it's scaled per year. So after 2 years, you would expect that they have the same level as an average student in conflict. So there's a kind of diminishing. But we have only an 18-month study, so one has to be careful in extrapolating this. Well, then you can do this for mother and so on. So mother, there's more conflict with the mother overall than with other relationships, with father. Actually, in all close relationships, there's a significant overall effect, except for the new peers. You know, they begin friendly, they are new, you are happy with them, you chose them. So there's less conflict, but this conflict is increasing, right? So after about 14 months, the effect has gone. And then it approaches probably the average of the old peers. Yeah, it's slightly higher than for other relationships, and it's stable, more or less. So these are things you can, I mean, this is just to illustrate how this could be done. Just a graph of one of the results. Here you have the years at university, 1 to 1.5 years, 18 months. You have the father, the scores, father low in N and father high in N. These are not nice graphs. These are outputs of HLN directly. And you see, of course, you have a huge effect of the father. There's always more conflict with the father than with other relationships. Very close relationships have more conflict than average relationships, but neuroticism makes it different also. Okay. Now we can extend this approach. This is very limited right now. By nonlinear functions of time, for example, quadratic time, then we have accelerated or decelerated growth. We can use exponential functions in time, contrast in time, so we can model effects of certain events. What happens in the first spring break with the relationships, for example. We can use, instead of time, another relationship variable, for example, emotional closeness, social support, relationship satisfaction. And then we can study the covariation of relationship quality over time. The second approach that Manuel talked about, either, you know, until now we describe with time, but then time is implicit, and we began to be interested in the covariation of the different conflicts across time, and this is really perhaps the most interesting topic, at least from a personality perspective. Compensations in relationships, conflict, and so on. We can apply this to diary studies on day-to-day changes or event-triggered changes, including lag predictors. Does conflict on a day spills over to the next day, and is is that spillover related to personality, and so on. We can add classrooms but you need at least 40 as the highest level if classroom differences in outcomes are significant and classroom characteristics can significantly explain them. Otherwise, perhaps you control some error by doing this, because if you are really studying full classrooms in educational context, you should add this if you have enough classrooms, just to control the clustering in classrooms. Even if you have no predictor at the classroom level, predictors could be, for example, teaching style or what you have, class size. And this allows for the study of moderation of lower order effects by classroom differences, cross-level interactions, for example, moderation of ethnic composition of the classroom, of the conflict with classmates, of own versus other ethnicity could be studied with this approach, or moderation by ethnic composition of the classroom, of the moderation of conflict with classmates, of own versus other ethnicity, by perceived discrimination of own ethnicity. It's not endless, but it's really, you can ask very, very complex questions, but the logic is straightforward. There are not many options now, like in mixture modeling, to decide. The model is straight. And you really have to think about what are the interesting questions. But there are limitations, of course. It's a linear model. At least 50 units at the highest level. If you have classroom and many, many other data, maybe 40 is enough. Your modeling time, this consumes constant uncorrelated measurement error, which is equivalent to growth curve models with constant uncorrelated measurement error. And this brings this talk close to the next one. We'll talk about this limitation here specifically. And you can also include latent variables, but one thing is clear, structural equation modeling fails, at least at the third. If you have 3 levels, it's impossible. And at 2 levels, it's very, very difficult, so forget it. If you choose this approach, you need multi-level modeling. Okay, that's it.